In 2022, NASA made the first step towards a technology that might one day save all of us: asteroid deflection. They did it by letting a small spacecraft hit an asteroid. It's taken a few years to analyze all the data, but in a paper that just appeared, astrophysicists report that the outcomes were not quite as expected. Just what did they find, and what does it mean for asteroid defense? I've had a look. The NASA mission was called DART, short for Double Asteroid Redirection Test, and if you've never Googled it, you should.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Mission liftoff. Falcon 9 with the DART mission on the way for humanity's first ever planetary defense test mission.
DART launched in November 2021 and got on its way to the double asteroid system of Didymos and Dimorphos. Dimorphos is about 160 meters wide or so and orbits around its bigger companion roughly once every 12 hours. They're about 11 million kilometers away from Earth, too small to see as anything but a point of light with ordinary telescopes. These asteroids are not in the main asteroid belt, but circle around the Sun on their own paths. They're not immediate threats to Earth. However, they're projected to come rather close to Earth in October 2184, where close means to within plus minus 1,300 kilometers. That means a direct hit has not been excluded, but we have 150 years to figure out what to do about it. It took the DART spacecraft almost 10 months to arrive at its destination. On September 26, 2022, it was then sacrificed to hit Dimorphos. This impact was seen by several telescopes on Earth and also in space, but they saw little more than evidence that the impact did happen. However, DART brought along a small Italian satellite called Cube. It separated from the DART craft a few days before impact and then flew past the impact site. It carried 2 cameras that recorded the debris trajectories. The new thing is now that we finally have the analysis of these recordings. Until now, mission planners expected most of the kick would come from the spacecraft's own momentum, plus a roughly uniform spray of fine dust and small pebbles. This expectation was partly based on NASA's Deep Impact mission from 2005 that had a probe hit a comet where exactly that happened. But the data now reveal this isn't what happened with the DART mission, not at all. The authors of the new paper say that on Dimorphos, the impact kicked out lots of boulders, some of them quite large, most of them rocketing off at high speed. And here's the kicker, quite literally. The boulder fragments carried more than 3 times the momentum of the spacecraft itself. Even more surprisingly, those boulders didn't escape evenly in all directions. They clustered into 2 main directions. The researchers believe that this is because the impact site itself had 2 bigger boulders that were basically annihilated. So what did this do to the orbit of the asteroid? The observations we have so far agree that the DART impact shortened the orbital period of Dimorphos around its companion by approximately 33 minutes. So it definitely did something. We'll know more after the Hera mission from the European Space Agency. It launched last year in October and should arrive at the asteroid system in late 2026. Its job is to map the impact crater in high resolution and also to measure how much the orbits of the 2 asteroids around each other have changed. And since it's a European mission, it'll also investigate whether the boulders are unionized and demand hazard pay. The overall effect of the DART impact on the path of the double system was totally negligible. This is because the DART spacecraft was so small. It had a mass of less than a ton, while the asteroid is estimated to weigh about 500 billion tons. The China National Space Administration also has plans for an asteroid impact test. They want to send 2 spacecraft to an asteroid that's roughly 30 meters in diameter. One spacecraft will do the impact and the other the observation for about a year afterwards. The mission is expected to launch around 2027 and the impact in 2028 at the earliest. What the new data analysis means is that asteroid deflection is more complicated than anticipated. It's not so much like kicking a ball, it's more like shooting clay pigeons. Though if you have an asteroid that's on a path to hit Earth, then any other path is an improvement. In summary, the good news is that we can move asteroids. The bad news is we don't really know what we're doing. So, business as usual. A French research ship has found more than 3,000 barrels of nuclear waste on the ocean floor. Some of them seem to be leaking, and they're now studying the situation further. Let's have a look. Nuclear waste in the ocean sounds shocking enough. Even more shocking is that dumping nuclear waste into the ocean was legal not so long ago under a convenient and widely used method to get rid of the stuff. Beginning shortly after the Second World War, many European companies from countries including the UK, the Netherlands, Belgium and Switzerland dumped over 200,000 barrels of radioactive waste into the Atlantic Ocean until the practice was outlawed in 1993. The barrels with the radioactive waste now sit at several kilometers depth and no one has any idea what's going on with them, which, come to think of it, also describes most theoretical physicists. This is why the French sent out a mission called NOTSOM for Nuclear Ocean Dump Site Survey Monitoring. It's a research ship that went out to the sea to the areas where the waste is believed to be. They set out to map an area of about 300 square kilometers to at least make a start at an inventory. The researchers on the ship used sonar to locate the barrels. You can see the barrels here in this sonar image as black dots. As you can see, they're aligned in stripes. These are almost certainly the routes along which the ships were going as they rolled the stuff overboard. The French research ship is also equipped with a diving robot that can go several kilometers deep down and has a camera to take 3D images. You see some of the photos it has taken here. According to some outlets, the French research organization CNRS, which is leading the mission, said they found around 3,350 barrels over an area of 163 square kilometers. They analyzed photos of about 50 of them and found that some of the barrels have leaked unknown material, probably the binding agent bitumen. My French isn't great, but I think it translates to, yeah, that's probably not good. It means basically that the radioactive waste, if it's not leaking already, isn't far from leaking. But they haven't detected increased levels of radioactivity, at least not yet. They have taken samples of the water, ground and sea life and returned them to labs for further analysis. So for now it's Schrödinger's barrels. Possibly leaking, possibly not, but definitely rusting. How alarming is this? We know that most of the waste in these barrels comes from laboratories or industrial applications, not from nuclear power plants. That means, for all we know, it's mostly mildly radioactive with a half-life of some 100 years, not the 10,000 years that people worry about for the highly radioactive waste from nuclear power plants. In other words, if we just wait a few centuries, it'll be fine. If you think that sounds irresponsible, wait until you hear about our climate policies. Still, that this stuff is potentially leaking onto the ocean floor is, well, not great. You'd expect any radioactive material to dilute very quickly in the water, though the details will depend on ocean currents. There's still a risk that some of it will end up accumulating in plants or animals and somehow make its way into the food chain. Can't we just, get this stuff back out of the oceans? Yes, but that'd be very expensive, and I think no one wants to do it. Also, if we bring it back up, people might notice, which, as we all know, is the worst possible outcome in politics. And also, then what do we do with it? So what can I say? On the one hand, nuclear waste on the bottom of the ocean is clearly bad optics for the nuclear industry. It'll be water on the mills of nuclear energy opponents. On the other hand, it's not of immediate concern. It is, however, a curious reminder of how unconcerned people were in the 1950s about environmental matters, so much so that they thought sinking barrels of nuclear waste to the bottom of the ocean was a good idea. Then again, who wouldn't like their tuna to glow in the dark? Thanks for watching. See you tomorrow.